definitions, I'll ask you maybe half a dozen of these. So that most of the stuff are things you're familiar with. In fact, all of it is. Now let's go through the work. Probabilities. So we got the jar. It turns out there's 100 marbles altogether. If you add them all up, and so the probability of red is the number of red marbles over all the marbles. So if we go to the definition of probability, which is in here somewhere, let's take a look at that. The ratio of the number of favorable outcomes for an event to the number of possible outcomes for an event. Okay, so there's 100 marbles. So that's the number of possible events that you can have. 33 of them are red, so the probability of getting a red is 33 out of 100. Now, red or blue, probability of red is 33 out of 100, blue is 24 out of 100. So the successful outcomes is 33 plus 24, or 57, and so the probability of red or blue is 57 out of 100. When you're doing an OR, you're going to add the two probabilities together. Not white, we're talking about a complement. So the complement of not white is 1 minus probability of white, which is 1 minus 8 over 100, 92 over 100. That reduces to 23 over 25. All of these are correct, though, expressions of the answer: 1 minus 8 over 100, 92 over 100, 23 over 25. At the restaurant, we're going to use the fundamental counting principle as defined above. So you've got all these different choices: appetizer, salad, salad dressing, entree, and dessert. So you're going to pick one of each: one type of appetizer, one type of salad, one type of salad dressing, one type of entree, and one type of dessert. So all the different choices taken together that you can make are 4 times 5. Let's just think about the salad. You got 5 kinds of salad and 7 kinds of dressing. So all the different kinds of salad you can have are 35. Combine those with the appetizer. The appetizer and the salad, how many different combinations are there? 4 times 35, or 140. Combine it with the 2 times dessert, 280, and then times 3 would be 840. So that's the fundamental counting principle for that particular kind of problem. The license plate problem: 3 letters and 4 numbers. The letters can't repeat, but the numbers can. How many possible license plates? Well, the numbers you can have 9999 or 7777 or whatever. So for each number, your choices are 10, 0 through 9. So 10 times 10 times 10 are the choices you have for the numbers, but you can't repeat the letters. So it's 26 times 25 times 24 times 10 to the 4th, and that all works out to 156 million. Okay, odds. Now the odds is the total number of successes over the number of failures. So the odds of a blue marble. So the odds of a blue marble are going to be the number of blue marbles over the total number of marbles minus the number of blue marbles. So that's 24 over 100 minus 24, or 24 to 76, or 6 to 19 reduced. The odds of a white or green marble, white marbles plus green marbles, over the total number of marbles minus white marbles plus green marbles. White plus green is 22. The non-white, non-green is 78. So it's a rate. So it's a. The odds are 22 to 78 or 11 to 39. Not getting a yellow. Not yellow marbles over the total number of marbles minus the not yellow marbles. Not yellow marbles are 79. Total number of marbles are 100 minus 79, which is 21. So it's 79 to 21. Measures of center. Find the mean, median, and mode for the yearly home run totals of Mark McGwire. So he played 16 years and he had all these totals. So to get the mean, you add them all up, divide by 16, and his mean is 36.375. Now, put him in order to get the median, 70, 65, 58, etc. Okay, so they're almost in order when you get them, but not quite. Okay, the middle two number, now I did them in descending order. It's probably better to do them in ascending, but it still works okay. So the median, since there's 16 numbers, 16 years that he played, the middle two numbers are 39 and 33. If he played 15 years, then the median would be the number in the middle. That would be number 8. Okay, but in this case, it's 39 plus 20, 39 plus 33 divided by 2, 35.5. Okay, then there's 3 modes. In other words, there's 3 doubles, as you can see. 39, 39, 32, 32, and 99. What is the range? The range equals max minus min, 70 minus 3, 67. Okay, what is the 5-number summary? Max, min, median, and Q1 and Q3. Now Q1 and Q3 are sub-medians. Median, Q1 is the median of the lower half of the data, the smaller half, and Q3 is the median of the upper half. So the lower half is 8 data items. So we got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so numbers 4 and 5, 1, 2, 3, 4, so 22 and 29. So Q1 is 29 plus 22 divided by 2, which is 25.5. And then Q3 is the median of the upper half, 1, 2, 3, 4, 5, 6, 7, 8. So it's 52 plus 49 divided by 2, which is 50.5. Okay. What is the IQR? It's the interquartile range. Q3 minus Q1. Okay. 50.5 minus 25.5, so the IQR is 25. We're going to make a box plot. Don't worry about outliers because there are no outliers, although I'm not going to get into, well, actually, no, let's not do that right now. Anyway, there are no outliers. If anybody cares to ask me about it, I will provide a proof that there are no outliers. But anyway, so we're going to make a box and whisker plot, and we make vertical marks at the min, the max, the median, Q1, and Q3. And we connect the 3 middle marks, Q1 and Q3, with horizontal lines to make the box. And then we extend horizontal lines from the middle of the vertical line of Q1 to the whisker to the vertical mark for the min, and we call that a whisker. And then we have a similar horizontal line going from Q3 to the max, and that's the other whisker. And the IQR is the box. So you got, here's Q3 minus Q1. So the IQR is always the box. The lower quartile, the lower 25% of the data is the whisker on the left. The max 25%. So in other words, this is from 0% to 25%. This is 25 to 50% right here in here. 25 from 50 to 75% is here. So this is first quartile, second quartile, third quartile. And then from 75 to 100%, the fourth quartile is right here in the whisker. The middle 50% is in the box. Make a stem and leaf. Okay, now how many stems are we going to need? Well, the data goes from units, that is years in which he had less than 10, up to 70. So we're going to, now if we want to just have each decade count as a stem, then we need 0, 1, 2, 3, 4, 5, 6, 7 as stems. Okay? And then for each stem, the amounts are ascending. So 3 and then followed by the 2 9s. Now, there's no teens. There's nothing beginning with a 1. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. In no years in his career, did he hit home runs where the total began with a 1. So with a 1 in the tens digit, no teens. But you've got to have the 1 on your graph to properly describe the distribution of Mark McGwire's home runs. You need to see the gap in the stem and leaf plot. If we made a histogram, we'd see a similar plot. Now, I'm not going to test you on histograms. I will test you on stem and leaves. I will test you on box plots. Okay, I'm not going to test you on everything. Anyway, so this stem and leaf shows the shape of the distribution. And that's it. That's how you make it. So there's 3, 9, and 9, and then he has 22 and then 29 homers, 32, 32, 33, 39, and 39. And this is where the median is, right here, and this is where you have a peak in the data, right here. Okay, we would call this, here's where one of the modes is. There's 3 modes, but this is the only mode we really care about. This does not really look like much of a mode in the data. As you look at the overall distribution, here is where there's a mode, right here. That is, there's a rise in the data, and then it goes down. Okay, anyway, then 42, 49, 52, 58, 65, and 70. And as I said, no outliers. Okay, expressions of a relation. This should be shown singular. Okay, so we have a set of ordered pairs, which is what a relation, one way that a relation can be expressed. It can be expressed as a graph, a table, or a mapping, and also as a set of ordered pairs, or as we've talked about in class, you can express it as words. Okay, so we plot the numbers. 5, 2, 3, negative 2, negative 2, 5, negative 2, negative 1, and 5, negative 3. And then we make them. So there's the graph right here. This is a discrete graph. The lines are not connected by a continuous line, and as you can see, this is not a function. Okay, so now we put them into a table, 5, 2, 3, negative 2, negative 2, 5, negative 2, negative 1, 5, negative 3. And then we take every unique member of the domain. Now there's only 5, 3, and negative 2 are the unique members of the domain, because 5 is repeated and negative 2 is repeated. So you can see it's repeated here and repeated here. Here's 5 here and 5 here as an x value, and then here's 5 and negative 1. 5. I'm sorry, here's negative 2, negative 1, and then negative 2 and 5. Okay. So the domain is 5, 3, negative 2. The range is 2, negative 2, 5, 1, and 3. And then there's the domain and range. 5, 3, negative 2, 2, negative 2, 5. In other words, it's an exact copy of the mapping. Determine whether each relation is a function. Okay, vertical line test. A vertical line, so imagine a vertical line going straight up and down. Now this relation is only 5 points. No vertical line, you can't imagine any vertical line that goes through more than one of these points. So this relation is a function. Same for this relation. Imagine a vertical line going through the graph. At no point on the graph does it hit the graph more than once. Also a function. Okay, and then 3, now we've got a mapping. Over here's the domain, here's the range. You can see -1 has 2 arrows coming from it. 4 and 5, not a function. Okay, so the rule is with a mapping, if a member of the domain has more than 1 arrow coming from it, it is not a function. Now we could have every member of the domain going to the same range. That's okay. That's all right. You still have a function, but you can't have multiple member. You can't have a member of the domain going to multiple ranges. Okay. 4, 5, and 6. All right. You can see right here. Here's 2 points that are on a vertical line. 2 points on a vertical line. 2 points. 3 points on a vertical line. Not a function. Here is a vertical line. Definitely flunks the vertical line test. Any vertical line is not going to be a function. And then here is a non-vertical line. Nice function. Okay, the vertical line test only hits it once at any point. Okay, so 4, 5, and 6. Now let's look at 7, 8, and 9. Okay. Now, when you're looking at ordered pairs to see if any of the x values in any of the ordered pairs repeat, you got 4, 2, and 6 as the domain. None of them repeat. You're fine. That 7 is good. 8, -3 occurs twice. It occurs in the first ordered pair and the second ordered pair with 2 different y values. Not a function. Number 9. The 2 x values are -1 and 1. They're both associated with 0, but that's okay. The fact is, they only occur once, so it's a function. And then finally, just plugging and chugging. Okay, the rule f of x equals 2x minus 4, so f of 4 equals 2 times 4 minus 4, which is 8 minus 4, which is 4. G of x squared minus 4x. G of 2 equals 2 squared minus 4 times 2. So 4 minus 8 is -4. F of -5, 2 times -5 minus 4, -10 minus 4, -14. That's that. Email me, let me know if you have any trouble, if you have any further questions.